Hey! So we've now made it through January, and we're somewhere in February usually at this point in the year, and we're starting our journey into fractions. So numbers in fractions is now a huge part of 4th grade. It used to be considered mostly 5th grade, but Common Core has pushed this particular skill down to 4th grade so that they can teach more abstract math in 5th and up, mostly algebra. So for this particular skill, the first one we're going to work on is numbers in fractions 1, which is equivalent fractions. Personal side note, I personally wish that they would not start with equivalent fractions as a skill. I think adding and subtracting fractions is conceptually easier to understand than understanding which fraction is greater than, which fraction is less than, and equivalency. And I do share that with your children, so you should be aware. To me, adding and subtracting is more concrete. The other thing that students have to do for this skill is represent the calculation, not only using an equation, but also being able to write it as an array or an area model. So when you and I learned fractions, we very rarely had to draw pictures of it. Now it is required. So what we usually start with is I give them a basic foundational ground rule, because in my experience, students find fractions confusing when they start mixing up what to do with fractions that are equivalency and adding and subtracting versus fractions that are being multiplied or divided. So I tell them it's probably a good policy for you to just get in the habit when you're talking about equivalent fractions or adding and subtracting fractions, just put them vertically like you would with an addition or a subtraction problem. In 3rd grade, they used fractions with the same denominator. So the first thing we usually do is review what they did in 3rd grade. First, review what the terminology is. This is the denominator. And what I tell the students about the denominator is that the denominator tells you what you would have if you had whole 1 or 1 whole set. And that's really important for them to understand, because fractions are numbers that are supposed to be talking about something that's less than 1 or less than a whole set, which represents 1 set. So that's the denominator. And the numerator is a much easier definition. The numerator tells you what you actually have. What you have. The denominator tells you what you would have if you had a whole 1 or a whole set. You don't. And that's why when the numerator is bigger than the denominator, we say it's improper, because fractions are supposed to talk about less than 1 or less than a whole set of 1, and that's why improper fractions are called that. So we do review that. We also review how it was covered in 3rd grade. So if you were comparing 2 fractions in 3rd grade, you would usually take a fraction like 3/4 and 2/4, and you would say which one was bigger, and you would say this one was bigger. And that solidifies their understanding of what the numerator is and the denominator is. But in fourth grade, we go deeper than that, and that's why pictures are so crucial. So the first thing you do is you ask them to give you two very simple fractions. So the first fraction I might ask for is 1/3. And another simple one, let's say 2/5. So as you can see, I've already put them vertically. The next thing I always ask the students to do is draw a picture of them. But for these two fractions, since the denominators are not the same, I want you to cut the fractions up differently because the denominators are different, and that way it's easier for me to talk about them. So for this one, I'm going to say, okay, how many pieces do I need to cut it into? 3, because that's what I would have if I had a whole one, but I don't. So I'm going to cut these into rows. What do I have? The numerator tells me what I have. That's how much I have. So since I cut this one horizontally, I'm going to cut this one vertically. The denominator tells me what I would have had if I had a whole. I would have had 1, 2, 3, 4, 5. And I always teach the kids when you're cutting fractions, please cut however, one less than however many is the denominator. That will cut them evenly, so you need 4 lines if you have 5. And also in fourth grade, we never make fractions in circles because it's very difficult to draw circular fractions neatly. And circles are mostly the focus of 6th grade. So please, please, please make sure your students always draw their fractions as rectangles or squares until they get to maybe mid-5th grade. It's just a good general rule. So now I can see I have them cut, and now I'm going to shade however many I have, which is 2. So now I can see that these fractions are different, but it's hard for me to talk about them and talk about equivalency because I can't tell which one has more. So for this particular fraction, how can I talk about them and say, well, they're the same? Well, if these were pizzas, I wouldn't even know how to compare them. So now I need to make them the same size pieces. So since this one was cut 3 times horizontally, I'm going to cut this one 3 times horizontally. And I can do that as long as whatever I do to the whole thing, I also do to the part that I have. So now I don't have 5 pieces. If I were to count them, I would say I have 5 3 times. 5 3 times is 15. And then I would prove it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I just cut this one up the same as this one was cut. And I also cut my shaded part, my numerator. How many did I cut it into? 3. So really, for all intents and purposes, I took my whole, which was 1, and I just chopped the one thing up 3 times, what I had and the whole thing. So now my shaded part, I no longer just have 2, I have 6 smaller pieces. So what I did to the one, I did to this one. Now I need to do the reverse. So this one was cut vertically 5 times, so now I'm going to do the same thing. 1, 2, 3, 4, 5. And now I cut it up 5 times, just like the bottom one was. And now I don't have 3 pieces, I have 15. And I also did that to the shaded part. So for all intents and purposes, I cut the whole thing up 5 times, which is why it says 1/3 times the equivalent of 1. And now I don't have 1 piece shaded, I have 5. So as you can see now, because the pieces are cut the same way, now I can see which one's equivalent and which one's greater or less than. 2/5 is greater by 1 than 1/3. In numbers and fractions 1, technically all students are required to do is recognize and create equivalent fractions and model them. But really, comparing two fractions with different numerators, meaning the same denominator, is really as far as they go with NF1. But NF2 requires that they show the comparison using a fraction model from the same whole. So proving it using a fraction model is what NF2 is all about. So I think you can see how if the students are used to always drawing a picture of the different fractions, and if they're used to always thinking about what does the numerator represent? It represents what I have. What does the denominator represent? It represents what I would have if I had a whole. Then they can easily recognize when the denominator is the same, you're talking about an object that's cut up in the same way. If they're used to being able to cut up fractions and know that equivalency also relates to if I have 1/2, how could I cut it? And if they're used to the procedure of vertically and drawing a picture, then they know that for this one they have two ways they could go. They could cut it horizontally once, which would then cause the denominator to be cut up twice as much and the numerator to be cut up twice as much. And now they have 2/4. They would also know that that's one fraction they could make. They could also cut it up this way. But then if they do that to the numerator, cut it up, they also have to cut the denominator up twice as much. And now that would be a different visual image of showing it, but the equivalency would be the same. So these models and being able to cut them up in many different ways is key to doing NF2, which is, are you really comfortable cutting up these different fractions and showing depictions in different ways? So now we're on to NF3, which is adding and subtracting fractions with the same denominator. And if they're used to modeling the different equivalent fractions in NF1 and NF2, adding and subtracting fractions is relatively easy when the denominator is the same. It's also still just about understanding that the numerator describes what you have, the denominator describes what you would have if you had a whole one. So if I were subtracting two fractions, I would put it vertically. I would draw a picture of both. And if the denominator were the same, then I would draw the fractions the same. So this says I have 2/3 and I'm going to subtract this amount. So this is what I'm taking away. So obviously if I'm taking that much away, what would that look like? That would look like I was getting rid of this. And what would that leave me with? One piece. Out of how many would I have if I had a whole one? That would be 3. And the big conceptual issue here is to make sure that children understand the denominator does not change because how many pieces you cut the whole into did not change. The amount you had changed. So for subtraction with denominators that are the same, that tends to be easy for kids to understand. The second part of this skill that's more challenging is I can add mixed numbers with like denominators. And this is again where pictures really help. Because the picture in this one would, if I had the same fraction, 1 2/3 plus 2 1/3, how would I draw a picture of that? Well, in this case, I would start with the whole. What do I have? I get a whole one. And I get all of it. I also have a fraction of a whole, and I get 2 of them out of the 3. Then draw the picture of the other one. 2 wholes, and I get them all. 1/3, and I get 1 of them. So now it's just a matter of adding it all up. I have 3 wholes so far, but if I add this one to that one, I would model it using an arrow, and then I would say this one's now empty, so what do I actually have? 4 wholes. Another way to say that is I have 3 3/3, and that's equivalent to 4. So the next skill is numbers and fractions 4. And now we start to deal with fractions in multiples. And we use the word multiples before we use the word multiply, because the first thing we want them to understand is if I were to say something like, how many 1/3 are in 2/3? I would say there are 2 of them, and this is where the picture making is key. I have 1, I have 2. The answer is 2. 2 1/3 in 2/3. So making sure that they can draw that visually is part of NF1-4. But also being able to model multiplying a fraction by a whole number is also part of NF1-4. So if I said I have 1/5 times 4, there's 2 visual ways that I can draw that. First, I could say, okay, I have 1/5. 1 2 3 4 5. And I don't just have it one time, I have it 4 times. So then I would just draw that same model 4 times for them to get that I have it not once, not twice, not 3 times, I have it 4 times. So what do I actually have altogether? Well, the visual model helps me understand what I have altogether. I have 1/5, 2/5, and I would actually have the kids move the part they have over into the first frame visually. 1/5, 2/5, 3/5, 4/5. I have 4 out of 5 possible. And the visual models are really, really important here because the children will see a 4 and they'll think they have 4 holes. They don't. And that's why it's so important for them to draw pictures. So that's one way to show it. The other way to think of this exact same problem is the reverse fact. So then, instead of drawing 1/5 and 1/5 and 1/5 and 1/5, now I'm going to draw 4 holes. I have 4. Yippee, I have 4. Uh-oh. But I only get the 4 1/5 of the time. So that means now I have to cut up each of my pieces, I have to cut my hole into fifths, and I get what the amount I have. Only 1/5 of the time, and then it starts to look like the fraction I originally made, but I'm thinking about it differently. I'm thinking, ooh, I get 4. No, I don't. I only get 1/5, 1/5, 1/5, 1/5 of it. So now we're at numbers and fractions 5. And numbers and fractions 5 is starting to get kids thinking about tens and hundreds. And we're doing that in preparation for understanding the relationship between fractions and decimals that both deal with parts of a whole or parts of a set. But fractions, the pieces can be cut into whatever size they want. Decimals are related to our number sense and base 10 system. They're only cut into multiples of tens, hundreds, and thousands, and multiples of tens. So getting them to understand equivalency of fractions in tenths and hundreds tends to be very, very easy if they had good, solid understanding of number sense and base 10 in September and October. But if they didn't understand number sense and base 10 in September and October, then they do tend to get a little confused about equivalency in finding fractions that are tenths and hundreds equal. So again, I would follow the exact same procedure I covered in comparing and ordering. I would say, since the denominator is different and what I'm really doing is equivalency fractions, then I would say, what is the equivalent in hundredths? Well, if I draw tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have one of them, then this one, I need to find out what's the equivalency. And since the denominator is different, I'm going to cut it the other direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I'm also going to cut it this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now that I have this one cut into 100 flat, I can see what the equivalent would be. It would be 10. So what really happened when I did that? Well, I had 10 and I cut it up 10 times. And if whatever I do to my numerator, I also do to my denominator, now I can see why it has to be 10, because my 1/10 got cut up in this one. So the next one is numbers and fractions 6. And numbers and fractions 6 deals with transitioning them to understanding how fractions and decimals are the same. So since we've had lots of practice with cutting up fractions, I now connect our number sense and base 10 work with the place value frame to fractions. So the first thing I would do is review our place value frame of ones, tens, hundreds, and then a new period in ones, tens, hundreds. But then the first thing we do is we talk about decimals for a minute. So we say that's the decimal line, and since these numbers grow 10 times greater each time, and we also know that each of the numbers gets 10 times smaller each time moving in this direction, what happens in our place value frame when we cross that line? Well, this is where I call that line the destroyer land line. And I say this is where we cut up objects. And we cut them up so that they become smaller. But decimals, you can only cut them up to make them smaller in bundles of tens, because decimals are based on our number system, which is based on bundling at tens. So let's say I have a 1 here. That means I have a whole 1. And in our terminology, I usually use a Barbie doll. And I say, if I had a Barbie doll and I had one whole Barbie doll, what would be the equivalent in decimals to one whole? Well, if I put a 0 here, I still have the equivalent of one Barbie, but the Barbie's been chopped up. How many pieces has Barbie been chopped into? So, if I had a Barbie and it was one whole Barbie, this would be equivalent to one whole Barbie, but because I put a 0 there, it's like saying I have the equivalent of one whole, but the one whole is now chopped up. Nine, 10. And if one piece were removed, let's say 1/10, then I would no longer have one whole. I would have 9 parts out of 10 parts of Barbie. And we use Barbie because it makes the students laugh and tends to lower their anxiety and their stress around it. They laugh a lot about chopping up Barbies, but it's a relatively silly concept that makes it something concrete and understandable to them. But you can use any object where you show them that basically decimals are when a whole object has been chopped up. So how would I write that in a fraction value? Well, because this place is worth tenths, this is equivalent to 9/10 because I'm in the tenths place. The next place would be chopped up 10 times more than that. And what's 10 times more than tenths? That's hundredths. The next place is what's 10 times more than that. This is where kids can get confused by the place value periods. They're going to want to say, this is 1,000. The next one, they're going to want to say 1,000,000, but 10 more than 1,000 is 10,000, and then 100,000, and then 1,000,000. Okay, so the place value frame changes a little bit once we cross the decimal line because it's always chopped up 10 times more. The whole or the set is chopped up 10 times more. The period names no longer apply in the same way. So finally, NF7 is not a fraction skill at all, really. NF7 is all about decimals, connecting decimals and describing decimals using fractions, but mostly understanding how decimals and fractions are related. So NF7 is where we start to compare and order. So the first thing I usually do for this skill is connect it to what they learned in 3rd grade, which is money. They learned that if I were to talk about $1.01 or $1.10 or no dollars and 1 cent or no dollars and 10 cents, how could I order these and compare them? Well, they do usually understand that the larger values are to the left and the smaller values are to the right, but you really want to make sure they understand that it's 10 times larger, 10 times smaller when dealing with money, and it's also when dealing with our decimal values. So getting them to understand that is a large part of this particular skill, and also word problems. So if I had a word problem like Sarah says that 28ths is greater than 5/10, who is correct? Explain your reasoning. Then being able to show that you understand that in many ways, not just saying 2/10 is greater than, or 5/10 is greater than 2/10. That's not enough. Being able to draw a picture of it, being able to model it, being able to tell me how much greater it is this one, and that's why it's key. So I would start with something like, well, what is that number? Well, in decimals, we read the entire number, then we read the last place value it was. So that would be called 28, and the last place value is hundredths. And this one is 5, and the last place value is tenths. How can I compare and order these? Well, we know from our previous work with fractions that when the denominator is not the same, and when we're dealing with equivalents, the first thing we want to do is put them vertically. And I would ask, well, how can I compare these two? Well, this one is 10 times less than that one. And I know from our previous work with fractions that if I cut this one up 10 times more, as long as whatever I do to the numerator, I also do to the denominator, then the equivalent fraction for this one is that. So now I can have a conversation about which one's bigger and why. This one's bigger, and it's bigger by, what's the difference between 50 and 28? It's bigger by 22 hundredths.